Why simple molecules decide the fate of entire civilizations. It never looks dangerous at first. Just a few atoms, arranged simply, behaving exactly as expected, until suddenly, history bends around them. Civilizations do not rise and fall only because of wars or leaders. They rise and fall because of chemistry, because of molecules so small they escape attention, yet powerful enough to decide who eats, who thrives, and who disappears. Today, the same quiet forces are shaping supply chains, energy crises, and global stability in ways few people truly understand. To see why, we have to go back to a time when survival depended entirely on chemical balance. Soil fertility, clean water, preserved food. Every society, no matter how advanced, rested on reactions happening beneath the surface. When those reactions worked, populations grew. When they failed, collapse followed. At first, people believed abundance was endless. Crops would always return. Resources would always replenish. The chemistry of nature seemed reliable, even generous. But this belief ignored a crucial truth. Chemical systems have limits. Push them too far, and they respond without mercy. One small molecule, produced naturally and later synthesized by humans, became the dividing line. In the right amount, it meant nourishment and growth. In excess, it meant poison land and fragile ecosystems. Entire economies reorganized around controlling it, often without understanding its long-term effects. What made this molecule so powerful was its simplicity. Easy to produce, easy to transport, easy to misuse. It slipped into soil, water, and air, quietly altering reactions that had taken centuries to stabilize. At first, the results looked miraculous. Harvests expanded, cities swelled, famine retreated. But beneath the surface, chemical balances were shifting, setting the stage for consequences no civilization had prepared to face. As use expanded, the molecule became invisible through familiarity. It was everywhere, so it stopped being questioned. Farmers relied on it. Governments subsidized it. Industries scaled production without hesitation. The chemistry worked, and that was enough. But chemistry always responds to pressure. As concentrations increased, reactions shifted. Soil chemistry changed first. Microorganisms that once recycled nutrients began to disappear. Water chemistry followed, carrying excess molecules far from their point of origin. Rivers transformed. Lakes lost oxygen. Entire ecosystems fell silent. What made the problem harder to see was delay. Chemical consequences do not always appear immediately. Sometimes they wait years, even decades. By the time effects became visible, the molecule was already embedded in global systems. Scientists began to notice patterns that didn't align with expectations. Crops required more input for the same yield. Water treatment grew more complex. Natural buffers failed. The molecule that once symbolized progress was now destabilizing the very systems it was meant to support. Attempts to correct course revealed another problem. Removing the molecule was harder than adding it. Chemical bonds had already formed. Cycles had already shifted. Reversing the reaction demanded energy, resources, and time societies were reluctant to invest. This created a quiet conflict. Short-term survival versus long-term stability. Feed the present generation or protect the future. Chemistry offered no moral guidance, only consequences. And once again, humanity found itself dependent on a reaction it no longer fully controlled. The molecule had become a lever, quietly deciding which regions prospered and which struggled, not through intention, but through chemistry itself. The tension reached its peak when limits could no longer be ignored. What once felt like control now looked like imbalance. The chemistry that fed billions was quietly eroding the systems that made feeding possible at all. Scientists traced the problem back to the reactions themselves. Not failure, but success taken too far. Excess molecules overwhelmed natural cycles. Feedback loops broke. Instead of renewal, accumulation took over. The very efficiency that made the molecule valuable now amplified its damage. Communities began to feel the strain unevenly. Some regions thrived briefly, extracting maximum benefit. Others absorbed the cost. Water sources collapsed. Fisheries vanished. soil hardened into lifeless ground. Chemistry did not distribute consequences fairly. Efforts to redesign the reaction intensified. Precision delivery, controlled release, alternative molecules. Each innovation promised balance, yet introduced new uncertainty. Every solution altered chemistry somewhere else. There was no perfect fix, only trade-offs. This was the emotional peak of the story. The realization that a single simple molecule could both sustain and threaten civilization. That progress built on chemistry is fragile, and that ignoring chemical limits always leads to reckoning. The molecule itself had no intent, no agenda. It followed physical laws flawlessly. The conflict existed entirely within human choices. How much to use, where to apply it, when to stop. Chemistry had revealed an uncomfortable truth. Civilizations don't collapse suddenly. They drift slowly, guided by reactions no one feels until it's too late. The turning point did not arrive with panic. It arrived with data, with patterns repeating across continents, with the realization that the chemistry supporting civilization was quietly undermining it. What made this moment so powerful was its simplicity. Nothing dramatic had changed. The same molecule was being used. The same reactions were occurring, but scale had transformed effect into consequence. Chemistry does not forgive repetition. It compounds it. This was the climax of the story. Not a discovery, but an understanding that even the simplest molecules can become architects of history. That abundance created without balance always demands payment later. And that chemistry, once unleashed globally, cannot be negotiated with. Slowly, priorities began to shift. Monitoring replaced assumption. Limits replaced excess. Scientists, policymakers, and communities started asking different questions. Not how much more can we produce, but how long can the system endure? Not what works fastest, but what lasts longest. The resolution is still unfolding. New chemical strategies aim for harmony rather than domination. Reactions designed to cooperate with natural cycles instead of overwhelming them. Progress measured not only in yield, but in resilience. This story is not about failure. It is about responsibility. Chemistry gave civilizations power far beyond muscle or machines. But power without understanding always reshapes the future in unexpected ways. What happened here is not confined to farms or laboratories. It is a pattern repeated everywhere chemistry meets scale. Energy, materials, medicine, each simple molecule carries the weight of long-term consequence. Sometimes the smallest shift in perspective becomes the beginning of a new future.